Hey yo, so this is Andrew, and today we're back with Trig Identities version 2.4 unit test walkthrough. Please have a copy of the unit test with you, but if you don't fret. I will put a screenshot of the questions to the right before we go over them. So, without any further ado, let's get started. Question 1. We would like to find the range of the function y equals 3 arc cos of 2x minus pi. Quick recap. Here is the graph of y equals arc cos of x. The domain is from negative 1 to 1, and the range is from 0 to pi. Thus, the range of our function will go from 0 to 3 pi. And that is the end of question 1. Question 2 asked us to find the domain of y equals 2 arctan of 1 over x squared. Another quick recap. The graph of y equals arctan of x looks like this. The horizontal asymptotes at y equals plus or minus pi by 2. And the function is defined for OX. This means that y is equal to 2 arctan of 1 over x squared is defined at OX except x equals 0. In other words, x must not be equal to 0. We are asked to find the asymptotes of the graph of y equals to 5 cotangent of 2x plus pi by 3. You can either memorize this, or you can simply cast cotangent in terms of sine and cosine. And we know that the function is going to have vertical asymptotes where the denominator is equal to 0. That basically means we have to solve this equation. So 2x plus pi by 3 is equal to k pi. X is therefore negative pi by 6 plus k pi by 2. Since we are only interested in the interval between 0 and pi, our asymptotes are pi by 3 and 5 pi by 6. So the asymptotes are x equal to pi by 3 and x equal to 5 pi by 6. Questions 1 to 3 are rapid fire questions. Question 4 should not take you that long. We now have to solve this equation. Cosecant is 1 over sine. So we have to solve the equation. Sine of 2x minus pi is equal to 1 by 2. If you're not sure how to proceed, just sketch the unit circle. Cos x on the x-axis, sine of x on the y-axis. We want to solve the equation sine of something equal to 1 by 2. And it will give you two roots, the big one or the smaller one. 2x minus pi is equal to pi by 6 plus k2 pi, or 2x minus pi is equal to 5 pi by 6 plus k2 pi. Solving for x. And now we only take the roots that are in our domain. So 7 pi by 12, 11 pi by 12, 19 pi by 12, and 23 pi by 12. And that is the end of the question. Question 5 is a little trickier. We're asked to solve this equation. Now, we notice that there are two trig functions here, cotangent and cosecant, and we would like to reduce it into one single trigonometric function. So, why don't we change the cosecant into cotangent? How? Recall that cotangent squared plus 1 is equal to cosecant squared. Therefore, we can just use this identity to obtain a hidden quadratic equation. Now, what do we do with this term? Number one, the period of cotangent of x is pi. So we can simply get rid of this. Period of y equals cot of x is pi. Furthermore, cotangent is an odd function. Y equals cotangent of x is odd. Recap. An odd function is a function where f of x is equal to negative f of negative x. And now we officially have a hidden quadratic equation to solve. Factorizing this guy, we know that cotangent squared has to be positive, so this is not an option. So basically, now we have to solve these two equations. Cotangent of x is equal to root of 3 when x is equal to pi by 6. The second option is when x is equal to negative pi by 6 plus k pi. Thus, all of the solutions within our domain are pi by 6, 5 pi by 6, 7 pi by 6, 11 pi by 6. Question 6 is another equation, but this time we are asked to show this equation has no real solutions by considering the range of each function. So let's look at the left-hand side. Y equals 1 over pi arctan of 3x minus pi. Recall from earlier that the range of y equals arctan of x is between negative pi by 2 and pi by 2. Changing the argument, doing horizontal transformations on the curve does not change the range. And then we're going to multiply everything by 1 by pi. 1 by pi arctan 3x minus pi less than 1 by pi, 1 by 2. So we know that the range of the left-hand side is between negative 1 by 2 and 1 by 2 exclusively. Let's look at the right-hand side. y is equal to 1 over 2 x squared minus x plus 1. We all know how to find the range of this function. And the quickest way is to complete the square. As we can see, this term is greater or equal to 0. Therefore, y has to be greater or equal to a half. The range of the left-hand side does not overlap with the range of the right-hand side. Therefore, the equation has no solution. If you would like to have a visual representation of this is not drawn to scale, obviously, but just to give you an idea of what we were trying to do. This is our left-hand side. We know that the maximum is at 1 by 2, and the minimum is at negative 1 by 2. Our function on the right-hand side looks somewhat like this. It takes the minimum at 1 by 2. The minimum value is at 1 by 2. And as we can see, the two functions do not intersect. Because they do not intersect, the equation has no solution.